Okay. So I can send you via email, but I cannot get a USC.
Are you not allowed to?
No, I'm not allowed to get a.
Okay.
Yes. Hello, everyone. My name is Dusun from Adobe Research, but this work was done while I was at Bosch Research before I moved to Adobe Research. And this is a work with Zoe and Lin, my colleagues at the time. So DIY is a highly the popular activity nowadays all over the globe. When you go to internet, there are tons of websites about DIY, from like a furniture building to cooking to auto mechanic. So there are lots of resources you can utilize. But as a novice user, DIY is such a challenging task, mainly due to the limitation of DIY articles. So to illustrate why, let's take an example of this DIY article. This is a typical template. You have some final product image and some preparation material list, and then step-by-step instructions. But reading this content and understanding, applying it, if you are a novice user, is such a challenging task for a couple of reasons. First of all, the terminologies may be difficult to understand. Descriptions sometimes, is loosely described. The contents are static. It never adjusts to your competence level. And the most important reason, when you do a DIY project, there is no professional around for many cases when you are stuck. What if you have a question answering system which can provide answer when you are stuck? So you might wonder, can my 7-year-old son do it? Or in this case, the tutorial doesn't describe the size of a drill bit, but you might wonder, what size of a drill bit should I use to tackle this project? To computer scientists, router means different things, so you might wonder why I need a router in this project. So when you ask all these questions, if there is a question answering system, certainly it will be very, very helpful for novice DIYers. So there was a project goal. It was a research project, and Bosch had a BoschDoIt.com, which contains lots of DIY materials, DIY project descriptions. And our goal was to build a question answering system, question answering system for the users who use this website. So for this example tutorial, if somebody asks this question, then ideally we want to provide the answer. Also, we would like to provide an explanation about how this answer is derived. So particularly, we tackled two types of questions. The first type is a domain question. So this is not project specific. These are the questions for the domain knowledge, such as the definition of the terminologies or the typical procedures in using some tools. For this type of questions, we prepare some canned answers. Basically, they are the mini text, mini tutorials, and then we use some information retrieval technology to retrieve these canned answers. More interesting question type is a project level questions. So these are the questions specific for projects. The reason why they are interesting, many of the questions, not only the retrieval-based some technique, but also some reasoning-based technology. So as an example, this question type requiring asking about some detailed explanation, so simple information retrieval cannot do it. Another example is like questions about alternative actions. So instead of using paint sprayer, because this is specified in the DIY project, but you don't have it. Instead, you have a paintbrush. So can I use it instead of a paint sprayer? So this is a very, very common question people ask. By the way, all these questions are from the user study, so they are not like a demo purpose question or whatsoever. So they are collected through the real user study. So this is a high-level system architecture, very standard the architecture used in most of the question answering system. In the back end, we have a knowledge base implemented upon Stardock, which contains basically knowledge graph of very, very different types of knowledge, from domain knowledge to project knowledge to product knowledge. And then the front end, we have like a 3 steps process to process the question. So I'm going to talk about the knowledge base in the next slide, and then we'll talk about the three-step process. So the first part of a knowledge base is basically a taxonomy of concepts. We built these concepts by analyzing the DIY tutorial documents. And we have 300 of the entity type, entity concepts, also 150 action concepts. And each concept is mapped with some lexical phrase and lexical vocabularies which are used in our question understanding phase. And all the knowledge representations are grounded upon this concept description. This is an example of a project knowledge representation. So the left side is basically the representation of the required materials, required tools. The right side is basically a hierarchical structure that describes step 1, 2, 3, and then step 1.1, 1.2, and so on. And all these things are like connected using some relations we predefined. And they are built using a semi-automated manner. We first apply natural language processing information extraction technology and then did a post-validation to ensure the quality. This is an example of a domain knowledge representation which describes domain knowledge. Unlike the previous two, this was pretty much done by manually. The existing automated NLP technology is not accurate enough to produce high-quality representation. So for the domain knowledge graph, we pretty much did a manual engineering. And then finally, we had a product knowledge graph, which is basically automated transformation from the relational database. So this is a back-end knowledge graph part. And then I'm going to just walk through how the question is processed with an example question. So suppose that you don't have any power tool for tackling some particular project. So you might ask, what is the total price of the power tools needed in the project? The first step is a question answering, question understanding. We use a sequence labeling just by an LSTM model to produce this kind of a frame structure. So we do like a question type detection, which is basically intent detection, and then tackle it as a slot filling problem. We also do a grounding so that all the lexical phrase are mapped to concepts we defined in the knowledge base. So this is the output, example output of the first process. And then for each intent type, we have like a specialized question answering engine. For this particular one, we use a Sparkle template to generate the Sparkle query using the template frame output generated from question understanding part. And then we just send this Sparkle query to the knowledge base to get the answer, and the answer generation provides the answer. So this is a retrieval part. As I said, our system also employs some couple of reasoning-based engine. So this is one example. For the explanation detail question type, we use some graph matching, semantic matching type of reasoning. So just to illustrate how we do, so let's say this is the real example from one of our project. It says a pre-drill a hole before driving screws. It specifies screw size, but it doesn't say what the size of the hole should be. And if you're a novice user, you don't know what kind of the drill bit you have to use. So you might ask, like, explain the pre-drilling step in detail. Then ideally, this is the system's output. Choose a drill bit of 4 millimeters. Since the target material is wood, choose a wood drill bit such as blah, 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 product. The way we do it, I'm going to just explain at a high level. Everything is now in knowledge graph. So we have a project knowledge graph. We have a domain knowledge graph, which talks about how to drill. We also have a product knowledge graph. And then we combine all this knowledge graph into one gigantic graph, which is basically the answer to this question. And then we translate that question into this natural language. Another type of some reasoning-based question answering, we have a paper last year in ISWC. So if you are interested, you can take a look. We use answer set programming to tackle the question about alternatives. So the project says you have to use a jigsaw to cut some lumber, but you don't have a jigsaw. Instead of you have a table saw, you might wonder, can I use a table saw instead of a jigsaw? These questions about alternatives is one of the very, very common questions DIYer asked. The way we do it, we convert question, domain knowledge, project knowledge, all the constraints into logical predicates, and then apply answer-type programming to see whether not recommended predicate is inferred or not. If it's inferred, we also trace the derivation tree to generate the explanations. Basically, the derivation tree is an explanation for the answer. So we did it took about like a 1.5 year to build this prototype system, and then we did some preliminary evaluation at the end of the project. We couldn't do a final like A/B testing or whatsoever, but just to see whether this work is like useful or promising to the user. So we recruited amateur 20 DIYers and then prepared these 5 questions. And intentionally, we picked these 5 questions. These are not the obvious questions you can easily answer using web search. And then we compared our system against web search. In this case, web search is Google, but I didn't name it. Yeah. Anyway, so by using web search, the failure rate is very, very high because if you are a novice user, it's now obvious how to use the contents retrieved by the web search in answering these questions. Also, the total time taken in answering these questions were very, very high. This is a very, very promising result for our research because a question answering system will immediately provide the answer and provide the explanation. Also, we did some poster survey, and this is one of the answers. We basically asked the DIYers to score the satisfaction level with a web search, where obviously it was very low, but with a question answering system, at least for these 5 questions, their satisfaction level was high, which shows the promise of this kind of knowledge-based question answering system. So this is our final slide, and before I wrap up, I just want to share some lessons I learned from this research project. In the NLP community, information extraction is a very, very popular topic to build a knowledge base. But for more advanced question answering, still manual knowledge engineering matters. We had to do a lot of manual knowledge engineering to build this system. Also, again, in the NLP community, most of the question answering research is some kind of a retrieval-based question answering, either retrieving a word, phrase, or a document. But as you saw earlier, many questions, real questions that real users ask, you need some kind of a reasoning beyond just a retrieval. The final lesson I want to share is, even though our system is named as question answering, it's not just question answering. Ultimately, it's a help system. To the help system, giving a yes or answer is not important. Well, it's important, but more important is why the answer is a yes. And they want to know how the answer was derived. So providing explanation is a very, very important thing. And I think this is with the symbolic logic, symbolic stuff and the logic-based one, this is a very, very straightforward to do, and it shows the promise of those technologies. That's it. And No, we didn't. So we asked the participants to find the answer for these 5 questions. So they can ask any kind of questions. So did they document how they were actually creating the search engine, the Google search engine? We didn't record those queries. Yeah, we didn't record all these queries. There might be some things to learn from there as well as to how these questions are actually. Right. Yeah. We didn't record. Yeah. The whole purpose of that experiment was whether the web search is a good tool for helping the novice DIY users in tackling those things. But yeah. Did you train those users on your system before you actually let them use these questions? I mean, did they get some kind of... For using the QS? No, there was no like pre-training.
Well, I don't know if it's quick. The question might not be that long. So, I mean, Google made quite a splash a while ago in providing, good search results on the web, and they've been making progress towards providing answers to questions on the web. But I wonder if this is the right question, right? Because it seems to me the missing context here is the decision-making context in which someone's engaged. When you're looking for things on the web, you typically have a decision, a problem that you're trying to work through. And I'm wondering if you've looked at this from a decision support context, which would expose much more about the context of the information requirements and decisions that people are trying to make, rather than simply trying to provide an answer for the question that you get at the moment. Thanks.
Right. Yeah, that's good point. That's good point. Thanks. Yeah.
So for this domain, you had about 300 tools in a knowledge base. Do you think that this solution is scalable for a bunch of DIY projects, or might it get confused, like if you're talking about a bit and in programming versus a bit in a drill?
So whether the approach can be scalable, is that the question?
Do you think that you could continually add more domains to this and it would still be able to distinguish between what you're trying to talk about?
Yeah, I think scalability, I mean, it's not like an open domain thing, so all the concepts are defined. The only thing is like new projects and so on. And if you have a really good a converter which can convert the DIY article into knowledge graph, then I don't see any problem in scaling this.